Good morning, everybody. Welcome to my talk about using code generation to create better apps. Because why write code when a computer can do it better and faster? Next. A little bit about me. I'm an Android developer for about 5 years now. I worked at an agency and did a lot of projects. I worked almost with the full stack of Android, from creating custom ROMs to simple Wear apps and everything in between. Now I work at a company called Carify, where we do a e-health platform for mental illnesses. I also do some occasional backend work in PHP. Well, I'm not proud of that. I also help run the blog of my wife. I'm the technical part, so I have to fix all the bad things in WordPress. And you can find me on Twitter at that Twitter handle. A little bit about the place I work. It's Carify. We create an online platform for e-health usage. We try to treat patients that go to a psychiatrist for mental illnesses like depression or stuff like that. And we try to blend the treatments with part online and part offline, so you can have better treatments and measure if patients get better easier. We do a lot of communication and data information about medical history. Well, this is how it looks on the website part. This is not me, of course. Yeah, and we're being used in the Netherlands mostly. It's about we're the biggest biggest company that does this in the Netherlands, and we try to work with big institutions to make the whole process of administrating and communication with the patients better. Also for the clients that use this, it should also be easier to go to their treatment and participate more easily. Well, what I'm going to talk about, it's code generation. What is code generation? Why would we use it? What are the use cases to use code generation? Why would we want to use it? A little bit of how it works, but it's not really technical because there are already a lot of presentations and a lot of tutorials on how to create annotation processors and stuff like that. But it's a little explanation how it should work. I'm also going to mention some existing libraries and already tools that are out there which you can use in your projects. And I'm going to show you how to implement them in Android. Well, what does code generation mean? When I started searching researching for this presentation, you enter code generation and you go to Wikipedia, and this is the first thing that comes up. In computing, code generation is the process by which the compiler's generator converts some intermediate representation of source code into a form of machine code that can be readily executed by the machine. Well, that got me thinking, because a lot of people say, oh, I don't use code generation because it sucks, the code is crappy to read. But in a sense, because we write Java, we are already doing code generation, because we write Java source code, and the compiler takes that and turns it into Java bytecode, which gets interpreted by the machine. So we already do some form of code generation, but not actively doing it with annotations and stuff. Well, as I mentioned, I'll explain where we can use code generation, what are the use cases for it. The data access layer for serializing or accessing data, which are pretty mundane tasks, and the code you would write for that is also pretty repetitive and easy to understand. So a code generator can easily be created to do that. It also helps reduce boilerplate code and code you don't want to keep and maintain, like equals or hash code. Every time you change something, you would have to update it. And with code generation, you can just change the field and it gets updated every time it compiles. There's also data binding. There's the Android data binding, which is part of the SDK. And there are also some libraries that do some binding of views. And of course, dependency injection, which is also the code that's needed for dependency injection is also relatively simple to generate. But if you want to write it yourself, it gets a bit, hard to maintain. And the code generator is a great example for dependency injection. Well, as I mentioned, the data access layer. If, for instance, on Android, we would try to save something in the database, and you would do it the proper Android way, you would create a contents value, put in the key values, the key pair values, and create some form of SQL string, and then you drop that everything in a method, and Android will execute that code for you. The biggest issue with this is that everything is a string, so it's not typed to the type in the database, but to a string, so it doesn't do that checking for you. And that's something that you can, you will only notice that when you install the app, run it, and it executes the code and tries to update or change something in the database which doesn't match, and you only see that at runtime. And with the code generator, you can generate the fully typed code for accessing a database, and it's also make sure that if you define the table with an integer, that you have to input an int instead of a string, which has the value of 1. For instance, the generated code would look something like that. You can update the person class, which is represented by the table person. The person field about is filled with the column name, and you put the value student in it. And then there's like the query builder language you can use to create the query actually and execute it. And versus the Android part, which is more error prone, and you would see the errors in runtime. This part would probably not compile if you, for instance, try to enter the 21 SA string instead of the int. It will give you an error from, hey, you're trying to put in a string and we can't compile. You have to fix that first. Another part is serializing data, transforming it from JSON or to parsable. If you look at the handwritten part of the person class to implement parsable, all this code has to be written to make it parsable, but this doesn't do anything yet. And you have to manually add the fields in the write to parcel and in the protected constructor. And then if you add a field to the class and you want to change the name to it, you have to update it everywhere. And if you add a new field and you forget it, it doesn't get saved. And you also might notice that only when you run the tests or when it's actually installed on the device. And then you'll see, hey, the data's missing. Oh yeah, I have to compile again and add the field to the write to parcel and the constructor. If you use something like auto value, which is an annotation processing library, you can annotate the class and make it an abstract class and implement parsable, and the annotation processor will generate all the code you see here in the background, and you don't have to maintain it and make sure that the fields are properly set and stuff like that. Well, as I mentioned, there's also something like binding data. The Android SDK offers a binding where you can bind your views to the actual code. As you can see here in the XML, you define a variable which is binded to a user class. And you can use it in the XML and set the text directly. And in your own code, you only have to call the data binding class, set the user, and it's done. And every time you want to change something about the user's info, that gets automatically changed in the view. And normally you would have to write like the find view by ID and then set text and have somewhere a way to get the user class and do that, which is a lot of code for doing a really simple thing. And this is supported by the official SDK, so it's an Android part of the SDK plugin. So it's not some external thing you can use and then think, hey, the developer is not maintaining it anymore, which is a good part. There's also something like a butter knife, which is also an annotation processor, which does the view binding. So instead of having to find the view by ID everywhere to get the field set in your activities or fragments, you can just annotate them with the bind view at the ID of the view, and then call the class that's generated for you by the annotation processor. You can also do click handling, and in the next slide you see you can also bind resources like strings or colors, and all this code gets generated for you in the compiler, and it generates you can see it here, a example activity underscore binding, and that's the class that does the actual hard work of find view by ID and setting those values to the class. Well, then we also have dependency injection. I don't know if anyone already uses something like Dagger or Dagger 2. This is the classic example you see when you look into Dagger 2, how to set it up properly, which is kind of abstract. But it does show that it can be rather simple to generate the code for this, because you create a thermosyphon, which also needs a dependency called the header. And instead of like new header, it just gets injected for you by Dagger. And the header is provided by the drip coffee module. And in the component interface, it creates a whole graph of all the dependencies you annotated with inject, or at the field you annotated it with inject. And it creates a whole graph for you, which injects that every time you instantiate the class. Why would we want to use code generation? It does reduce the boilerplate code you have to write and maintain. So that could speed up your development if you don't have to write code you don't want to look at after you write it the first time. Another big part is compile time exceptions. Instead of having the app crash when you do something wrong, the actual compilation doesn't work. So you get an error from, oh, this field doesn't exist in your XML layout, or errors like that, or the typing is wrong, and you can fix it beforehand, which leads to less crashing apps and less buggy apps. Also, a big thing is code optimization, because the code that gets generated is actual Java code. You can run it through ProGuard or DexGuard or any tool like that, which does the optimization on the bytecode and should make your application a bit faster. And another big part is you don't have to test the generated code. The generated code is in a separate folder in your project, and if you delete that and just press compile again, it generates exactly the same code. And you don't have to write unit tests to check if that code works, because the libraries and the tools you use are already tested that they generate the correct code by the library creators. So you don't have to check those implementations yourself. You do have to write, of course, tests for your own code that use part of the generated code. But these days they try to make the calls to the generated code as little as possible. So you only have one place where you call the generated code, and the rest is an interface or an abstract class that you already defined yourself, so it doesn't give errors when the compilation fails or something like that. Also explain a little bit about how code generation works. There are two ways to generate code. The main thing is to use an annotation processor, and the other thing is to use a plugin in the build system. They're a little bit different, and they have advantages and disadvantages. The first thing is using a plugin in your build system or in your IDE to generate the code, which usually works with an external file in some language like JSON, or this is SQLite, which gets parsed by the code generator, and it creates a class for you. Here, for instance, you create a table and you create an update statement. And this generates a Java interface for you that you can implement on your data classes. And the advantage of having this as a plugin or a plugin in your IDE is that every time you change the file, the code gets generated automatically. So you don't have to press compile before the codes get generated, and you can call it in your own code. So this works really fast, but that also means for every generator that uses a plugin, you would have to add that to your build system and to your IDE to make it work properly. So that can get a little bit bigger if you have a big project with a lot of plugins and stuff like that. It can make it a lot harder to understand your project. The other one is annotation processing, which is part of the Java compiler. It's been there since Java 1.5, so it is part of the actual Java compilation steps. And all you have to do is annotate your own classes with either auto value or entity for the data library. And in the background, this gets generated by the Java compiler. It generates the new code for you, and you can use it. As you can see, for auto value, for instance, it generates a new auto value underscore person class. And that's the one you instantiate or use. But in your own code, you just use the abstract class person with all the methods that you defined already. So you're not calling into methods which might not exist at some time, because you only have to use your own abstract class. Well, this approach also works pretty good. Some might say this slows down your builds and makes it complexer to build your apps. But if you look at the actual compilation, it happens quite fast. I have a little animation for that. So you write your own code, your own Java code, and you annotate that with any annotation. What happens when you start the compilation? You say, hey, these are the Java source files, and these are the annotation processors I have defined in my project. And the Java compiler will say, hey, there are annotations in it. Let's look through all the files, get all the annotations, and then pass them to the annotation processor to see which annotation processor can handle which annotation. And then the annotation processor says, hey, I'll handle these annotations. It generates a new file for you, a new code, new Java code, in the same step. And the fun thing is, the generated code can also have annotations. So it can do multiple steps of generating code. So the newly generated code also needs to be scanned. So what Java does is it puts it back in the queue for scanning. And the original code gets compiled to bytecode and completed. And then the newly generated files are scanned again. Hey, are there any new annotations? No. Then we're going to compile this to bytecode also. Well, how does this work? There are two ways to do the code generation. You can either use something like a templating language. If you have really simple code, you can create a template for it and just fill in the blanks with the names you use. But there's also something like Java Poet, which is an actual Java jar, which you can use to generate code. And everything is defined in specs. Like you have a method spec, and you pass in the name, like main. You pass in which modifiers do you want, public, static, and what is the return type, void. So this will generate a public static main method with the arguments, and it adds the statement in the method, which just print out of hello Java Poet. And so you can make you can program your whole approach to how you need to generate the code, which can get really interesting if you want to do some more complex things. This is, for instance, created by Square, and I think also Google also use Java Poet to generate their code generation tools. Well, you might wonder, well, which tools are there already to use? As I mentioned, the dependency injection, we have Dagger, which is the dependency injection library. It was first created by Square, and the first version was written, I think, by Jake Wharton and some other Square engineers. And these days, Dagger 2 is created by Google, because they are now maintaining that code. For instance, AutoValue, which creates immutable types of your data classes. This is a library that is created by Google, and they have like a whole family of auto libraries which do service injection or service generation, factory generation. This one makes your classes immutable, which is a nice thing to have sometimes. If you want to do ORM, object relational mapping, you can use something like requery, which is a library that generates the models and has a whole query builder interface which uses those models to generate typed code. It's a really nice library, but it's also pretty big because it's not specifically for Android. You can use it also on the Java platform. It supports all kinds of libraries like Postgres, MySQL, MS SQL, a lot of databases. But it also works on Android, and it's quite nice to use. You can also use something like SQLite, which is also a plugin by Square. It does the query and cursor mapping, so you only generate a model class and the mapping to that. It doesn't do any relational part. It's just pure SQLite and then generating the classes for you. There's also Butterknife, the library by Jake Wharton, which does the view and the resource binding. And there are still many more on you can find on Android Arsenal. And now the tricky part: how are we going to use those libraries in our project? It's actually very easy. We only have to add a plugin to our main Gradle file in the root folder, and then apply the plugin in your app module, and then say, hey, I want to use this annotation processor or this library, and you're ready to go. And it works out of the box. You don't have to configure anything. These days, you can also start using the new Jack compiler, which started to support annotations, I think, a few weeks ago. It's still, you have to still enable it with the flag, but it could be interesting to see how that goes. Maybe it speeds up your builds or not. Well, are there any questions?